Exercise worksheet 4B, question number 11, part A. We're doing the homework corrections. Find the nth term of the sequence 4, 8, 12, 16, 20. This is simply the table of 4. So its nth term is 4n, which is the answer for part A. Question 11, part B. 11, 20, 35, 56, 83. Now the difference between 11 and 20 is 9. Then it's 15. Then it's 56 minus 35. /21, and then it is 27. So this is second level common difference, because the second level common difference is 6. So this is a quadratic sequence. So its nth term will be in the form an square plus bn plus c. A is second level common difference divided by 2. So 6 divided by 2, which is 3. So A becomes 3. So this expression becomes 3n square. Now we're supposed to find B and C. Now write the original sequence again. Then subtract minus 3n square from this. So minus 1 square is minus 3. Minus 3 times 1 square is minus 3. Minus 3 times 2 square is minus 12. Minus 3 times 3 square is minus 27. Then minus 3 times 4 square is minus 48. Then minus 3 times 5 square is 75. We add these, we get 8, 8, 8, and so on. So the final expression will be, the nth term will be 3n square plus 8. B in this case is 0, which is the answer for 11B. Question 12. Find the nth term of the sequence 5, 11, 21, 35, 53. How do we go to 11 from 5? Add 6. How do we go from 11 to 21? Add 10. Then add 14. Then add 18. So this is a question of second level common difference, also called quadratic sequence. An square plus bn plus c is its general term. A is 4 divided by 2, which is 2. So this becomes 2n square. Next we write the original sequence again, 5, 11, 21, 35, 53. From this we subtract 2n square. So 2 times 1 square is minus 2. Then minus 2 times 2 square will be minus 8. Then minus 2 times 3 square will be minus 18. Then minus 2 times 4 square will be minus 32. And then minus 2 times 5 square will be minus 50. Find the sum. We get 3, 3, 3, and so on. So simply the final answer will be 2n square plus 3 B is 0 in this case as well. Question 13, part A. Find the nth term of the following sequence. So let's look at the numerator. The numerator is 1, then 2, then 3, then 4, then 5. So nth term of 1, 2, 3, 4, 5 is simply n. Then look at the denominator. It's 3, 4, 5, 6, 7. So it's still the original sequence, but we've taken away 2 numbers from it. So the nth term of the denominator is n plus 2. Or you may use the first level common difference formula for the denominator as well, a plus dn minus 1. Part B. Nth term for 0, 3, 8, 15, 24. The difference between these two is 3, then 5, then 7, then 9. The difference between these is 2, 2, 2. So this is second level common difference, also called quadratic sequence, whose nth term is an square plus bn plus c. A is always this value divided by 2. So a is 1. So we get 1n square. Next we write the original sequence 0, 3, 8, 15, 24. We subtract minus 1n square from it, so we get minus 1 here. Minus 1 into 1 square is minus 1, then minus 1 into 2 square is minus 4, then minus 1 times 3 square is minus 9, then minus 1 times 4 square is minus 16, and minus 1 times 5 square is minus 25. When we add these, we get minus 1, minus 1, minus 1, minus 1, minus 1. So our nth term is simply 1n square minus 1. B is 0 in this case as well. This is the final answer for 13B. Question number 14. Part A. Find the nth term of each of the sequence. 1 over 2, 1 over 4, 1 over 6, 1 over 8, 1 over 10. So the numerator is not changing, it's always 1, so its nth term will be 1. The denominator is the table of 2, so the nth term for the denominator is 2n. Part B. How are we going from 1 to 5? By multiplying with 5, then 25, then 125, then 625. So we are multiplying with 5 in each case. So this is an exponential sequence. For that you use the formula a r n minus 1. A was the first term, which is 1, times r is this number, the ratio, which is 5, times n minus 1, which is the answer. Where is that? Here. This is the answer for part 40. Part 15, question 15, part A, 15A, which is find the nth term of the sequence 16, 19, 22, 25 and 28. So we adding 3 over here, then again plus 3, then again plus 3, then again plus 3. So this is first level common difference. So for its nth term I write 3n, 3 because of this. Then my first term right now is 3 times 1, 3, but the actual first term is 16. So I need to add 13 to it to get to 16. So plus 13. Answer for part A. Part B. Nth term for 1, 3, 9, 27, 81. So we're multiplying with 3 in each case. 1 times 3, 3, 3 times 3, 9, 9 times 3, 27 and so on. Its nth term is a r n minus 1. This is an exponential series. A is the first term 1, r is the common ratio, which is 3 power n minus 1. So this is the answer. Classwork question for today, question number 16, part A. find an expression for the nth term of each sequence. Part A is 11, 7, 3, minus 1. What is happening over here? We have to subtract minus 4, then again minus 4, then again minus 4 to get to the next term. So this is simply first level common difference, also called a linear sequence. So for that I write minus 4n, and then right now my first term is minus 4. When I substitute n is equals to 1, I get minus 4. The actual nth term, first term, is 11. So I need to add 11, 12, 13, 14, 15 to it to get to 11. So my final the nth term of part A is minus 4n plus 15. Part B, 3, 6, 12, 24. 3 is being multiplied to the first term to get the second term, then times 3 to get the third term, then times 3 to get the fourth term. So this is exponential series whose formula is AR power n minus 1. A is the first, 2 was being multiplied, 2 was being multiplied in each case. So multiply by 2. So 3 is the first term, then 2 is the common ratio, power n minus 1, which is the answer. Question 17, part A. The n term of a sequence is an square plus bn. Write down an expression in terms of a and b for the third term. To find the third term, we have to substitute n is equals to 3. So this becomes a 3 square plus 3 times plus b times 3. So simplified answer will be 9a plus 3b. This is the answer for part A. Part B, the third term of the sequence is 21. So 9a plus 3b is equals to 21. The sixth term is 96. So how do we find the expression for the sixth term? Instead of n, substitute 6. So a 6 square becomes 36a plus bn becomes 6b. Now we get we have two simultaneous equations. How do we solve that? We can multiply. This is equation 1, this is equation 2. I can multiply this with minus 2. So this will become minus 18a minus 6b is equals to minus 42. Now this is equation 1 dash. I can add these two equations to eliminate variable b. So I get 18a here, 6b and minus b gets cancelled, is equals to 54. So a is equals to 54 divided by 18, which is 3. Now I have a, the value of a, I can put it back anywhere in any of these three equations to get the value of b. I'll use the first one. So 9 times 3 plus 3b is equals to 21. So 3b is equals to 21 minus 27, which is minus 6. So b is equals to minus 2, which is the answer. Question 18, part A. Here are the first three terms of a sequence. The nth term of the sequence is un is equals to 1 over 4 n square n plus 1 whole square. Work out the value of u39. That means we have to find the 39th term, which means instead of n, we'll write 39. So u39 is equals to 1 over 4 39 square and 39 plus 1 whole square, which is 40 square. This will give us 308 608 400, which is the answer for part A. Clear screen. Part B. Here are the first three terms of another sequence. By comparing this sequence with the sequence in part A, find a formula for the nth term of Vn. So we need to compare these numbers. This was 1 cube 1 and this is 2 cube 8. This was 1 plus 8, and this was 2 cube 8 plus 4 cube is 64. Then this was 1 cube 1 plus 2 cube 8 plus 3 cube 27, and here we have 2 cube 8 plus 4 cube 64 plus 6 cube, I believe, is 216. Yes, 216. So what is happening over here? 1 is changing into 8, then 9 is changing into what? 8 plus 64, 72. Then 9 plus 27, 36 is changing into 8 plus 64 plus 216, 288. So what is happening? How is 1 changing into 8, and how is 9 changing into 72? How is 36 changing into 288? By multiplying each number by 8. 1 times 8 is 8, 9 times 8 is 72, and 36 times 8 is 288. So all we need to do is multiply this given nth term with 8. So 1 over 4 n square n plus 1 whole square times 8. So we get 2n square n plus 1 whole square, which is the answer. Question 19, part A. The first 4 terms of a sequence are this. The nth term of the sequence is Tn is equals to 1 over 6 n times n plus 1 times 2n plus 1. Work out the value of T23. So simply instead of n, write 23. So 1 over 6, 23 times 23 plus 1 times 23 times 2 plus 1. This will give us the answer 4324, which is the answer for part A. Question number 19, part B. A new sequence is formed. U1, for U1 we subtract T2 minus T1, for U2 we subtract T3 minus T2, and for U3 we do T4 minus T3. Find the value of U1 and U2. So for part 1, U1 is actually T2 minus T1. T2 is this 1 square plus 2 square minus T1 is this 1 square. So we get 4. Then for U2 we subtract T3 minus T2. Now when we subtract these, we'll only be left with 3 square. So I'm simply writing 3 square over here is equals to 9, which is the answer for U2. Okay, part 2. Write down a formula for UN. Now what is U1 is 4, then U2 is 9, then U3 is will be the U3 will be 16, because when you subtract these two, you'll be left with 4 square, which is 16, and so on. So and the next term will be 25, and so on. So our sequence is 4, 9, 16, 25, which is actually 2 square, then 3 square, then 4 square, then 5 square. This is a square series, but we've removed 1 square from it. So its nth term will be n, not n square, but n plus 1 whole square. Okay, clear screen. Question 19, part C. The first 4 terms of another sequence are these. By comparing these sequences with one in part A, find a formula for the nth term for Vn. So we have to compare these and these, and from this nth term we have to generate an nth term for Vn. Alright, so 1 square is 1, here 2 square is 4, so 1 is changing into 4. then 1 square plus 2 square is 5, and here 2 square plus 4 square is 20. So 5 is changing into 20. Next, this number will be 14, and this number will be 56, and so on. So how is 1 changing into 4, and how is 5 changing into 20, and 14 into 56? By multiplying each number with 4. So we will simply multiply this nth term, Tn is equals to 1 over 6 n plus 1 2n plus 1. Multiply this with 4. When we multiply this with 4, we'll be left with 2 over 3 n plus 1 2n plus 1, which is the answer for part C. Question 20. A sequence is given by u1, under root 1, then under root 3, then under root 5, and under root 7. Find a formula un for the nth term. So we know the formula needs to have under root sign on it, because all these numbers have under root on top. And then what is the nth term for 1, 3, 5, 7? 2 is being added in each case. This is first level common difference, or the linear sequence. For that we write 2n. My first term is 2, 2 times 1 is 2, but the actual first term is 1. So I need to subtract 1 from it. So 2n minus 1 is the nth term for 1, 3, 5, 7. And the final answer will be under root 2n minus 1. Part B, find u29. For that, substitute 29 instead of n, and we get under root 57, which is the answer for part B. Okay, the homework for today is page 17, which is worksheet 4C, question 1 to question number 3. We'll do the corrections tomorrow. Allah Hafiz, take care.